Welcome back to the part 3 video of mobile communication system. As a part of principles communication system course, we'll be seeing all this. Let's explore VoIP or Voice over Internet Protocol, one of the most revolutionary technology in the communication. VoIP allows you to make a voice calls using the internet instead of traditional phone line. It works through gateways, which convert the regular voice signals from the telephone lines to the data packets that travel over IP networks. In mobile communication, these gateways can connect the GSM network with the internet-based system, allowing the seamless voice across both traditional and the digital platforms. Let's analyze how VoIP works. When you speak through a VoIP phone or a computer, your voice is first converted into digital data. This data is sent through a cable modem to the internet instead of using a traditional phone lines. At the receiving end, the digital data is converted back into the voice, allowing the clear, real-time communication between the two users. So VoIP uses the power of the internet to make calls faster, smarter, and more affordable than the conventional telephone. Now let's look at the GPRS or a General Packet Radio Service, which is an important step in the evolution of mobile data. GPRS is a packet-oriented mobile data service that allows users to send and receive data packets, enabling the features like mobile internet, multimedia messages, and online browsing. At the base station controller, the traffic is splitted. The voice goes to the mobile switching network as an standard GSM, and while data is to a new component called servicing GPRS, SGSN, servicing GPRS support node through the packet controller unit called PCU. The SGSN then communicates with the GGSN, which is called the Gateway GPRS Support Node, which connects the mobile network to the internet. In short, GPRS made it possible for GSM users to move from simple voice over calls to the real-time internet connectivity. Let's explore the architecture of GPRS, the system that made mobile internet possible. In this setup, the base station subsystem (BSS) handles the mobile communication with the user. Voice calls can follow the circuit switched GSM path through the mobile switching net center MSC to the PSTN, while the data takes a different route through the GPRS network. Here, the two key nodes come into the play: the servicing GPRS node and the gateway GPRS support node. These two manages to transfer the data within the network, and GGSN connects the network via an external IP network like the internet. Together, these components form a hybrid system that supports the both voice and data service efficiently. Um, Serving GPRS is support node SGSN, which plays the key role in GPRS network. This is responsible for managing the data, the packet delivery between the mobile services and the network. It handles the mobility management such as when a user devices sign ins or sign off or moves between the areas. It also manages the logical link control LCC, ensuring the data is transmitted reliably while performing the authentication and the billing functions. In short, SGSN act as the main controller for the user's mobility, data integrity, and the secure connectivity in the GPRS system. Gateway GPRS support nodes or GSN. Another key component is the in the GPRS. It acts as mediator between the GPRS backbone network and external data networks such as the internet. It manages the connection between the user mobile device and the online device. Additionally, it stores the user data, including the SGSN address, the subscriber profile, and the information required for the authentication and billing. In essence, GGSN serves as the bridge that links between the mobile users to the global internet securely and efficiently. The concept of PDP context, which is crucial for data transfer in the GPRS. PDP stands for Packet Data Protocol, and it addresses work at the layer 3 of the OSI model and the network. GPRS supports both X2.5 and the IP protocols, which means the PDP addresses can be in either of these formats. Each PDP address is linked to a GGSN, and the whole traffic data between the user and the public network passes through this gateway, ensuring the proper routing and the connectivity. Here's the PDP context actually works in the GPRS system. When a user connects to the internet, data travels from the mobile device to the BTS and BSC. From there, it reaches the SGSN, which manages the mobile and the packet delivery. The data then moves to the GPRS, GGSN, which connects the GPRS network to the external network like IP or X2.5. The setup defines a complete communication path and called the PDP context, enabling the smooth and efficient mobile transfer. It's like now we'll be seeing on attached procedure in the GPS communication. When mobile phone connects to the network, it first sends attached request to the SGSN. Then it identifies and authenticates the device by communicating with the old SGN and HLR, home location register. Once the authentication and securing is complete, the mobile is officially attached to the GPS network. Attach procedure, the first step that connects your mobile to the data network securely. We'll be seeing on the radio access RA and the location area LA. Updates help us to track a mobile device location as it moves across the network area. When a phone is switched on or enters a new area, it performs an initial registration and sends a location update request containing its identity and area details. The network then performs authentication and authorization to verify the user and to ensure the valid access. In simple terms, RA and LA updates allow the network to know exactly where your device is, ensuring the continuous and secure connectivity. Let's quickly summarize the key concepts from last few slides we have seen. The GPRS or a General Packet Radio Service enables the mobile network by transferring the data in packets. Its architecture includes SGSN for managing the user's mobility and GGSN for linking the mobile network to the internet. The PDP context defines the path between the device and the network. Then the attached procedure connects the user securely to the system, while RA and LA updates the continuously track the device's location within the network. Together, this process ensures the smooth, secure, and continuous mobile data connectivity across the regions. Thank you for watching. If you have any queries, you can put it in the chat box. Thank you all.